Hello everyone, I am Ashin. Today I want to talk about how to find out if the battery is about to fail. Basically, we just need to charge and discharge the battery to know the answer. If it requires less duration to charge and subsequently discharge the battery, that means the battery capacity has decreased a lot. SOH is very poor. That means the battery life is almost coming to the end. This is the report received from a car shop for my vehicle's maintenance. It says the battery's SOH is close to the warning line. You should replace it. I am uncertain about the method used to determine the warning line. But the battery has been used for 2 years. I'll replace it. To measure SOH, we need to know the current capacity. I am going to use common method to evaluate SOH. I will explain the basic concept of charging and discharging. Meanwhile, I will demonstrate both to you. In fact, there are charger and discharger on the market. But for the battery factory, it needs more strict control of the quality of the battery. So they usually choose the following 2 devices. One is power supply, the other one is electronic load. They're used to test the battery's charging and discharging process. Today, I plan to test this 12 volts lead-acid battery to observe its charge and discharge curve. Simultaneously, I calculate its SOH. Let's understand charging. Basically, it just apply a DC to the battery. Use PSW DC power supply by GW Instack, 80 volt, 40.5 ampere. Typically, individuals believe charging is just apply direct current voltage to a battery. That's right, this is really a way. This is called the constant voltage charging CV. But in fact, there are many alternative methods that currently exist for the purpose of charging. For instance, constant current charging, pulse charging. The method I'm going to apply here is called CCCV method, which combines 2 methods as I mentioned previously. This is a very common charging method. Divide the charging process into 2 stages. The first stage is the constant current CC mode. After the charging voltage crosses the threshold voltage, the charger then switches to constant voltage CV mode. But how much charging current do we need in constant current mode? For this battery, the nominal capacity is 9 Ah. It means that if you use 9 A for discharging, the battery power will run out in 1 hour. Should I use 9 ampere to discharge as well? I don't dare to do that because this current is too high. Large current will further age the battery. And I'm not familiar with the characteristics of this battery. I think we should be cautious. I will use the 0.1 C charging current, which is 0.9 A. Adopt a conservative strategy first. In CC mode, battery charges, voltage increases gradually. At what voltage level should it be switched to the CV mode? We can establish a maximum voltage limit specifically for the 12 volts battery in our system. Its limit is 14.2 volts to 14.5 volts. Basically, the limit is slightly higher than 12 volts. To maintain a conservative charging approach, let's use 14.2 volts as the voltage upper limit. During charging, when the voltage progressively increases and ultimately reaches up to 14.2 volts, the power supply switches to the CV charging mode. To implement the process, I am going to set the 0.9 A and 14.2 volts to this power supply. First, turn it on. We need to wait for a little while longer. As long as we set it properly, its charging voltage and current will stay within the range. Alright, we should now proceed by pressing the set button. Set. (14.2 volts). Then I set 0.9 A. 0.9 A. Okay, the settings are complete. Okay, let's charge it. All wires connected. Red is positive, black is negative. To avoid incorrect operation, I wrote a Python program to control the power supply automatically. The program includes the upper limit control. Voltage is 14.2 volts. The current is 0.9 A. These are all program controlled, although I have operated them manually. To prevent errors by manual operation during the process, I primarily rely on the program. This program can override and control all existing settings. This prevents wrong settings. The program retrieves the voltage and current data every 5 seconds. So we are ready to go now. Let me press the run button now. OK. The machine is now running smoothly. The process may take approximately 9 to 10 hours to complete. I think it may take more than 10 hours. I think we can just leave it alone and let the whole program run. Now I am going to pause the recording. Charging complete. Let's examine the chart. The voltage gradually increases during the charging. Once it reaches the upper limit 14.2 volts as we have set. After a while, the current then begins to decrease gradually. This part of the charging process is called CV mode. We don't require that much current. In the initial 9 hours of charging, its IV curve is perfectly aligns with my understanding of battery charging. This part has no problem, but after the 9th hour, you can clearly see the current curve increases rapidly. An unusual event occurred within the lead-acid battery, and it means the internal resistance of the battery decreases. Since this involves a chemical reaction, I am uncertain about the processes occurring inside the battery. To be honest, I am slightly worried. Therefore, I decided to stop the process of charging when it reached the 13th hour. In fact, I programmed the stop conditions. As you know, the current gradually decreases in CV mode. When the current drops below 0.1 A, the charging process stops. Obviously, this condition is not being met. So I stopped it manually. I have had this battery for over 4 incredibly long years. Throughout this period, I have not been consistently charging and discharging the battery as required. Perhaps this behavior is the main reason for the significant rise in the current as we observed. I don't know. If you have more thoughts on this matter, please leave us a detailed message for further consideration and review. I am also curious about how this happened. How much power have we charged into the battery so far? According to the chart, we have charged about 8 Ah electricity over a period of 13 hours. Its nominal capacity is 9 Ah. The capacities of 8 Ah and 9 Ah are quite close, so I assume it is fully charged. So the next step is to discharge the battery. We can calculate the capacity through discharging. I am curious if the capacity are the same between charging and discharging. We will find out later. How to discharge. It is necessary to connect a load to the power supply instinctively, but in reality we usually use CC mode for discharging and battery testing. As the battery discharges, the voltage gradually decreases. If you use a constant resistance load for discharging, both current and voltage decrease. It implies that there are two variables decreasing in the same experiment. Plotting the chart and understanding it can be challenging. If we intentionally keep a constant current, we can solely observe the voltage. After that, interpreting this chart will be straightforward and simple. Since the voltage decreases during discharge, if we try to keep the constant current, we need properly reduce the resistance during discharge. Does it mean we need replace the resistor during discharge? Indeed, we can't do it. That's why we need an electronic load. The electronic load device can adjust resistance to keep a constant current throughout discharge. This is Prodigit's electronic load 3316G. Electronic load can adjust the load in real time. Besides the constant current mode I mentioned earlier, it offers various load modes. For instance, it offers constant resistance mode CR, constant voltage and power CVCP. It offers multiple modes. Additionally, it has safety mechanisms. For example, you can set limits for voltage, current and power. The electronic load serves a purpose beyond a resistor. It serves the safety function. If you use the regular cement resistor as a load here, then it simply heats up without any safety mechanisms in place. That will be dangerous. That's why we need an electronic load. This electronic load even offers battery short test capability. The button for short test is located right here. Anyway, the short test is not today's topic. I just want to let you know why we need an electronic load while testing. After all, simply using a single resistor for charging and discharging tests, that would be quite reckless. Okay, I'll use the CC mode for discharging later. Therefore, I will set the load mode to CC. Set discharge current to 0.9 A, which is the same value as charging I mentioned. I will use the program to control it. You can disregard this particular setting. Regards to the stop condition for discharging. I will set the stop condition as less than 10.5 volts. The electronic load has a rear panel control interface. I use RS-232 currently, so I can write the program to control it, so I can simultaneously record the voltage and current while discharging. I wrote this program. Let's take a look. This is the instruction for operating the CC mode effectively. This 0.9 is the CC value I mentioned. I read the current and voltage measurements here. Here I save all data into a file. Right now, I'm pressing the Run button to observe how the discharging process go. Press the button. Here we have some numerical values appearing on the LCD screen. The screen displays the discharging current as 0.9 A. Surprisingly, we have an 11 volts power source here now. How does this voltage drop so quickly? This battery's been used 4 years. In fact, I find this battery weird when using it. Wow, it is 10.8 volts now. The stop condition is 10.5 volts. Perhaps it will soon drop to a voltage of 10.5 volts. I attempted to stop recording, but now I will continue. Keep watching to see if it dropped below 10.5 volts before stopping this video recording. It seems it may happen. Let's examine the program screen, currently showing a 10.588 volts voltage. The value decreases continuously. It is almost done. It's below 10.5 volts. It's over. The program should stop. Yes, the program stopped. So my battery has some problem for sure. Its capacity is quite low. If we try to calculate it, its capacity should be 55 seconds times 0.9 A. Then we get 13.75 milliamp hours. When we compared with the 8 Ah capacity we have charged previously, almost 99.8% battery power seems wasted. I believe this battery has some problem. I demonstrated a common battery charging and discharging method. Mobile phone and laptop batteries can be tested alike. The significant difference lies in the level of the test. For example, it may remove some test items for test efficiency. Or the battery may not be fully charged for transportation safety. If you need to conduct thousands of tests to collect comprehensive data for charging or discharging purposes. Or you need to add the additional temperature, resistance measurement. The entire test system becomes extremely complex. In this case, you have to write your own program to control all devices. And you may need to design a relay board for switching the charging or discharging current. Now you need to have knowledge and expertise in both hardware and software fields to build the system. At this point, you have to evaluate how much time you have to spend with it. So there is a charging-discharging system on the market. It's easy to use. Your requirements are pretty much covered. This is Prodigit's Battery Charging-Discharging System 9841. It integrates power supplies and electric loads. You can also install a temperature recorder if you want. Of course, their test software is also included. You can build the test procedure by yourself. Since everyone's individual requirements are different, this 9841 can be customized. So its actual appearance may differ slightly from this picture. If your tests go beyond charging and discharging, it involves any other test items. For example, if you need some measurements from oscilloscope, you have to integrate an oscilloscope for sure. Does it mean you need to write a program to obtain the test results? No, you don't have to. This is GW Instek's cyber physical system. It integrates a lot of instruments. And all the instructions are built into this system. Basically, you just need to set the test items. So in fact, this system is beyond more than battery charging and discharging. It can expand your test scope. It will be more convenient to use. The system is an IoT host inside. I will introduce this in the next video. Today I operated the real instruments and try to show you what is going on during charging and discharging. It can be challenging for individuals to do this kind of testing at home. I hope you guys learned significantly from today's video content. In next episode, we will talk about so many electric cars running on the road. How can we use these power resources efficiently? In the upcoming video, I am planning to discuss in detail about the energy management system. Don't forget to subscribe to the Strong Pi Lab. Goodbye.